Hi guys, I'm Easton, and today we're going to be learning about the shape, center, and spread for box plots. So real quick, just as a review for box plots, a box plot is going to show you the minimum value of a data set. And it's going to have the first quartile range, which is the 25% mark, where 25% of the data is below and 75% is above. You have the median right here, which is the middlemost data number. You have the third quartile right here, which is the 75% mark, and the maximum, which is the greatest number in the data. Don't forget, range is maximum minus minimum, and IQR is third quartile minus first quartile. And IQR again stands for interquartile range. So that's how you'd remember it's between the quartiles. Normal distribution, this is also just review. This is what it's going to look like. You can say something's normal if it's unimodal. So I'm drawing in the histogram here of the data. And as we can tell, the histogram is basically follows the curve, and unimodal, meaning there's only one maximum. Now, if there's a second bar that was greater like that, that wouldn't be unimodal. Unimodal meaning there's one high point. This is a second high point. So if this was the histogram, we couldn't say it was normal, but it's not. That's it. So it's unimodal and it's symmetric, meaning the tails, which are these lines on each side, are about equal length, and it's not skewed to either side, which we'll talk about next. Once again, this is a symmetric histogram right here. You can see the curve right here, and symmetric box plot as the IQR, the area between the first and third quartile is centered between both of the outer quartiles. So this is what a skewed left distribution is going to look like. As we can see, it's very long on the left side. And the hardest part about remembering skewed left is which if skewed left means it's on the left or right side of the line. Now skewed, kind of think of like stringed out, like it's like very thin on one side. Skewed, it's stringed out on the left side, as we can see here. This is also what the histogram and the curve will look like to the right there. As we can see, it's very strung out on the left side, very little on the right side. And that's that first quartile range right there. This is skewed right, obviously the opposite of skewed left, strung out to the right side. This is what the histogram and curve will look like on the right there. So that is the shape, and now this is what the center is. So these are two curves, and you can see skewed left to the left and skewed right to the right. Now, don't pay attention to the mode right now. We don't need to look at the mode, but let's look at the median and the mean, because this is something you're going to want to talk about when you're describing a box plot or a curve like this. Now, this is a frequency, right? So we know histograms. Now you learn about histograms, and it's basically just counting up how many of each number is in a data set and plotting it out like this. So that's the histogram. And so basically this is, you take all your numbers, right, and you see how much they occur, and then the higher the bar, the more the number occurs. So let's do a quick example. Let's say you have 5 numbers. You have a 0, a 5, a 5, a 5, and a 5. All right. Now this is your distribution. You have 5 numbers in this distribution. Now, what's the median? We know the median is the innermost number. So there's 2 to the left of this 5, to the right of this 5. So the median is that 5 right there. So median is 5. But let's take the mean. So now I already put these plus signs in here just to make it easier. We'll divide by 5, right? Because we're finding the mean. You add up all the numbers and divide by the total number of numbers. And that's giving us 20 over 5 equals 4. Okay? So the mean is less than the median, because the mean is 4 and the median is 5. Now, why is that? The median's the most middle number, and the mean is the sum. Now this 0 right here is y. The 0 is small, and it's dragging down the average of all those 5s added together. So this right here, this 0 and the 4 5s would be a left skewed or negative skewed distribution. Now, I know I added so many bars in there, but this tall one right here would be the 5s, right? That's where all the 5s are. And this one tiny one down here would be the 0. There's 1 0 and 4 5s. So these are the 5s right here. This is the 0. Most of them are right here, but the little 0 right here is dragging the mean down. So when it's left skewed like that, the mean is going to be the mean is going to be less than the median. And that's how you can tell, another way you can tell if it's left skewed. So if I said the mean's less than the median, you can assume it's left skewed. Now let's do an example for the right skewed or positively skewed distribution. Now, let me just finish erasing all this right here. Okay, let's do this the other way. Now, let's say we have a 10, 5, 5, 5, 5. And that's all going to be over 5 because we're finding the mean. And that's going to equal 30 over 5 equals 6. Now, our mean is 6, but our median, once again, it's the middlemost number, is that 5. Now, this time, the mean is greater than the median. And that's this right skewed right here. If this were a distribution, the little 10 would be right here, and our 5s would be up here. Or, not bad. 5 would be right here. In this case, we have a big one number right here, the 10, dragging down the mean, or dragging up the mean, that is, and making the mean bigger because it's creating such an effect on the mean compared to all these 5s, even though the median's still 5. So if it's right skewed, the mean's greater than the median. Let's go next page. Okay. Finally, we need to describe spread when talking about a box plot. Now, the spread is the range and the IQR. So that's real easy. The range is the biggest number right here minus the smallest. That's going to be about 1. And now this doesn't have to be exact, but we just want to be close. 1 minus negative 1 equals 2. Now we want to do the IQR, which is this middle guy right here. It's the third quartile, which is right here, minus the first quartile. Now that's about 0.4 minus negative 0.4. So when we do that, that's going to be about negative 0.8, or positive, my bad, positive. So you're going to say this has an IQR of 0.8 and a range of 2. Finally, let's talk about outliers. An outlier is a point in a distribution that is so far away from the other numbers that it's confusing us and it shouldn't be in that data set. It's like, I drive home from school every single day, and sometimes there's traffic, and sometimes, I hit red lights. But let's say one day I'm speeding, and I don't normally speed, of course, but let's say, one day I have to get home on time. I'm speeding, I'm going 20 miles over the speed limit. I hit every single green light, and there's no traffic. So I get home in like 5 minutes, and I live 12 minutes away. So most of the times getting home are going to be between like 12 and like 16 minutes for me, right? Let's say that's the normal time it takes me to get home. Well, that 5 is so far away from the 12 and the 16 of when I normally takes the range it normally takes me to get home that we're going to say this is an outlier, and we don't really understand why it's here, but it's skewing our results. Because if a big outlier, let's say like, that 5 minutes is right here, but all my other guys, my numbers, that's my median, my first quartile, my second quartile, my max right here, makes it skewed left. And we hate skewed left. We don't want skewed left distribution. So we're going to say it's an outlier, and then the minimum, we just do a dot for an outlier. The minimum becomes the next lowest number, and that would be my box plot, and that's symmetric and normal, and we like normal distributions. Now, how do we say that's an outlier, though? Because we can't go around saying every number is an outlier until we get a symmetric distribution. what we have to do is do a statistical test to see if a number is an outlier. Now to do that, what we're going to do is we take the IQR for this right here, it looks about 23, and we multiply it by 1.5. And now that's going to give us 34.5. Now, this is what we're going to call our star number. Now, with the star number, we're going to go to Q1 and Q3. At Q1, we subtract the star number, and at Q3, we add the star number. So that's going to create this area right here. Now, any number outside of that star number, there can be multiple, those are our outliers. So that 5 minutes, if we said our IQR, so I said most of my numbers are between 16 and 12. Let's call that my IQR. That's going to be IQR of 4. Times 1.5 equals 6. Then we go 12 minus 6 equals 6. And I said it was 5 minutes, so 5 is less than 6, so that's an outlier. Now, sorry, let's get to my example. This is, we're going to tie all this together, shape, center, and spread, and describe this box plot right here. Now, sorry it's flipped on its side, but I always like reading box plots when they're parallel to the ground. I don't know. We're going to start with shape here. Now, to me, it looks skewed right because this is longer than here. If you have a nice teacher, they might let you say that's symmetric. I don't think it's symmetric, but for sure what we can't say is that it's skewed left. And that's because there's a way bigger area on that right side. So saying skewed left would be completely wrong. So I'm going to say skewed right. Now next, we are going to talk about the center. Now, for the center, we want the median, and we don't have the mean, but we're going to say if the mean is greater than the median or not. Now, the median is this line right here, which looks about 25. So median equals 25. Now, I want you to take a second, pause the video, and I want you to tell me, is the mean greater than the median in this case, or the median greater than the mean? Now I'll give you a second. I actually need a second because I need to see for myself. But now let's say, earlier we called it skewed right? So I assumed you paused the video by now and looked. If it's skewed right, there's going to be a lot of really big numbers on this side, bringing up the mean. So we're going to say mean greater than median, as all the bigger numbers on the right side bring it up. Now finally, we have to talk about spread. The range, max minus min, is 45 minus 10 equals 35. IQR is Q3 minus Q1, which is going to be 30 minus 15 equals 15. And that is all you have to say. You don't have to check for outliers on this. But if you did, you take the IQR, 15 times 1.5, and add it to Q3, subtract it from Q1 to see if there are any outliers. But besides that, that's all you need to do. So yeah, I hope this was helpful. Thank you.